Hello, mic test. For this video, we will continue with the discussion of the topic steady-state devices, and we are now on compressors. Yeah. What are compressors? As mentioned, steady-state devices pa tayo. Included siya doon. It increases the pressure of a flowing fluid by reducing its volume, kaya compressor, may compression happening. And they are similar to pumps because they both increase the pressure of the fluid. And they can transport the fluid through a pipe. So, they are both used to transport the fluid. Pero, what's the difference between a compressor and a pump? Compressors, these are used for gases. Pumps are used for liquids. That's the main difference. I'm sure nakakita na kayo ng pump if may aquarium kayo. Sa laboratory ng 156, 155, meron ding pump. Yung compressor, I'm not sure, pero if nagme-makeup kayo, yung airbrush makeup, yun, gumagamit yun ng compressor. So, bakit iba siya? Ba't kailangan may separate na device for gases, but may separate device for liquid? Mainly because yung gases compressible. So, the compressor reduces the volume of gas, pero liquids are incompressible. So, the main action of the pump is to pressurize and transport. Let's derive the working equation for compressors. Beginning with the steady-state energy balance. Okay? Since negligible lang yung delta PE and delta KE, and then let's assume na walang heat loss or negligible lang siya. Yung compressor natin ay ma-reduce sa work shaft equal to delta H of flowing stream. So, therefore, if we express yung delta H na H2 minus H1, yan. So, this is our working equation for the compressor. And ano yung mapapansin nyo sa compressor? So, for example, ito yung flowing stream natin. No? Work is done, work is required. Work is done on the compressor. As compared sa turbines, sa turbine, di ba, ito yung flow ng turbine. Okay, so, expansion process naman. From a small opening to a bigger opening, and then work is done by the system. Okay? So, compressor, from a big opening to a small opening, tapos work is done on, so keyword is done on the system. Sa turbine, work is done by the system. So, please tandaan nyo, importante na ma-differentiate nyo yun. Una, magkaiba sila ng flow sa drawing, sa diagram. Iba yung direction ng work. We have also reversible and adiabatic compression. Ano ulit pag reversible at saka adiabatic? Diba delta S is 0. So, yung final mo na S, equal lang yan dun sa initial na S, kaya S2 equal to S1. So, it is said na pag ganon, isentropic compression yung process. And we have an isentropic work, meron siyang sub S. Therefore, if isentropic work mo ay work shaft S, yung corresponding ano niya, delta H is the isentropic change in enthalpy. So, for example, may graph tayo ng H versus S. Oops. Let's say, so yung H natin nasa y-axis, S nasa x-axis. And then, we have isobars P2 and P1. Same, we will undergo from point A to point B. And in a real process, diba, laging yung S2, okay, this is S2, yung S2 laging greater than S1 sa real life. Kaya, ang direction natin is towards increasing entropy, towards the right. So, this is the real path, yung nangyayari sa actual path. Delta S is greater than 0, is positive. So, if we take the change in enthalpy ng dalawang points na yon, ito siya. This is the change, okay, in enthalpy ng dalawang points na yon. Compare natin sa isentropic compression. Pag sa isentropic compression, delta S is 0. Therefore, vertical line lang yung path natin kasi S2 is S1. Diba? So, ito yun. Let's label yung final state na B prime. Okay? Therefore, change in enthalpy natin, ano napansin nyo? Mas maliit siya. It's a shorter length. Diba? Shorter length than this one. Therefore, yung delta H sub S is less than yung delta H ng actual. Anong masasabi nyo? Opposite siya pag sa turbines, diba? Sa turbines, the delta HS is greater than the delta H actual. Okay, so this is yung actual. This one is the actual. So, opposite siya. Meaning, yung work, since equal lang yan, di ba, working equation natin, ang working equation natin, so walang S yan, is yan. So, meaning yung work required for an isotropic compressor is less than the work required for an actual, okay, compressor. Kailangan alam niyo yan by heart, no? Yung sa turbines at saka sa compressor, kung ano yung mas mababang work. Yung isentropic ba? O yung actual? Opposite sila, yung turbine at compressor. So, meron akong tinatandaan na story para maalala ko yun. Parang nag-i-imagine ako ng utopia. Yan. Sa utopia or ideal world, 'di ba? Sa ideal world, ang mga compressor doon mas mababa yung required na work para mapaandar. Kasi dito sa actual world natin, 'di ba, mahal ang kuryente kasi yung compressor dito, mas mataas yung kailangan na work. Pero doon, mura lang yung kuryente. Kasi yung mga compressor doon, mas mababa yung kailangan na work. Tapos, sa utopia din, pag turbines naman yung pinag-uusapan. Sa utopia, yung mga turbines, mas malaki yung napoproduce nilang work kumpara dito sa real world na yung mga turbines dito, mas maliit yung napoproduce nilang work. Ganun. So, parang, ko lang siya para maalala ko. Story. Yan. The work requirement of isentropic compression is the minimum work. Okay, tandaan. It's the minimum work required by a compressor operating adiabatically. And, yung actual compression requires more work because of irreversibilities in the process. And when we calculate for the efficiency, diba pag nagka-calculate tayo ng efficiency, yung smaller value lagi yung nasa numerator. Kasi yung efficiency natin is less than 1. So, ano ba yung smaller between the two for compressor? Diba smaller yung isentropic delta HS compared sa delta H actual. Smaller yung isentropic work compared sa actual work. Yan. This is for compressor. Pero remember, for turbines, baliktad siya. For turbines, ano yung nasa numerator? Diba? Delta H actual ang nasa numerator over delta HS. So, baliktad sila lagi. Okay, so for the sample problem, next video na natin siya isolve.